Next thing we'll cover absolute value inequalities. They behave the same exact way normal inequalities do and normal absolute value functions do, which is just super similar to the way linear functions work, okay? So, let's just think, okay? If we're looking at the absolute value of x is less than 3, right? Okay, we want all points, right, all values that are of a distance less than 3, right? So if we go 0, 1, 2, 3, like this, right? We want an open circle. And anything between here to here is fair game, right? So go like that, right? Because all of these numbers are at a distance of less than 3 from 0, okay? On the other side, well, let's think. Is -1 a distance of 3 or less from 0? Yes, it is. What about -2? And what about -3? What about -4? Right? Give guys a second to think about it, and then we can kind of regroup. Assuming that you've already thought about it, I hope you paused. You'll find that -1 is also less than a distance of 3 from 0, right? -1 to 0 is just one step, right? Same with -2, and almost same with -3, right? -3 is exactly a distance of 3 from 0. So you can include it because we want strictly less than. So this is actually what your graph will look like, right? And if you go all together, it's going to be from here to here and everything in between, right? That is to say, you have -3 is less than x is less than +3, right? That's how you can write absolute values for less than, right? You can write this as -3 to +3, like that, all right? And of course you can do all sorts of fun equations, right? Yeah, I'm just gonna trim this out, and that's okay. Let's do something a little more interesting, yeah? Let's say we want the absolute value of x is greater than 7. Let's do greater than or equal to 7, okay? So we want all of the values where the distance from 0 is 7 or more, okay? So certainly you don't want points like 1, 2, 3, 4, 5, right? So 1 is no good, 2 is no good, 3 is no good, 4 is no good, 7 is good. 7 is okay, right? Because 7 is a distance of 7 or more, right? So you can block that in. And of course, anything bigger than 7 is fair game, right? And what about on the negative side? Well, using that same mentality, right, that same method, you go 1, 2, 3, 4, 5, 6, 7, right? -7 is a perfect distance of 7 from 0, so you can count that. Things in here don't count, right, because the distance is too close. And of course, anything more negative than -7 is fair game as well. And if you look at it like this, right, if you look at this graph, you know that this is going to be -infinity to -7 inclusive, union 7 to infinity. And because there's no intersection between these two sets, right, there's no overlap, there's nothing to combine. So big picture, it's pretty easy, right? So let's do one more. Let's do a slightly harder one, okay? Let's do example, actually, you know what? Let's do the example problem from the textbook, example 1, okay, we're on page 39. Let's say we have absolute value of 3w plus 1, close, -4 is less than 7, right? Well, again, we want to treat it like an inequality, like a normal inequality, excuse me, which means you can treat it like a normal equation almost, right? So if you have this, let's isolate this piece first. This gives you 3w plus 1 is less than negative 4 plus 4 is 0, 7 plus 4 is 11, right? And in that same manner, we know that the inside has to be within this radius, right? So we can split it as if we go back to what we did over here, right? I'm saying there's a radius, right? This is the same as writing it like this, right? You're saying the distance is bounded, that's what we call it, bounded between whatever this is and whatever this is, right? So you can actually write this guy as negative 11 is less than 3w plus 1 is less than positive 11, right? Because again, we're saying, do as I say, not as I do, okay? Just visually, this is how we can visualize it. Don't actually do it like this, because it'll confuse you more, and you will probably do it wrong. Negative 11 is here, positive 11 is here, and this piece in the middle, I'll highlight it in orange or purple, is 3w plus 1, yeah? And we're going to do some linear transformations on it, of course, so it'll look different, right? If you subtract 1 on both sides, right, you end up with negative 12 is less than 3w, which is less than 10, right? You divide by 3 on all sides, right, or in all sections, and that gives you negative 4 is less than w is less than 10 thirds, right? That's reasonable, that makes sense, right? Because then what you can do is you can just write this as negative 4 to 10 thirds, which is the same as graphing it as negative 4 to 10 thirds. Open here, squiggles here, right? That's it. That's absolute value inequalities for less than. Now what if we do greater than? I think the US will find greater than very interesting. So for example, let's say we have the absolute value of x is greater than 5, right? As a graph, 0 is here. Well, we want a distance of more than 5. So 1, 2, 3, 4, 5. 5 lives here. We want more than 5, so it does not include 5. Da-da-da-da-da-da. Right? In the same way, let's go in the negative direction. 1, 2, 3, 4, 5. This is negative 5. Don't want to include it. Da-da-da-da-da-da. Just like that. Right? We're not counting this bit in the middle. So our interval will be negative infinity to negative 5, union 5 to infinity. Essentially, you're looking at a radius that's not inclusive on the inside and inclusive on the outside. Okay? So, what if you did a slightly harder example? Let's say you had absolute value of x plus 7 is greater than, not 2, 10. Well, you would solve it as you would usually, right? Subtract 7 on both sides, abs x is greater than 3, right? Which means you want outsides. Your graph will look like 0 lives here, negative 3 lives here, positive 3 lives here. You don't want these, and it's not the middle because the distances here are too small, right? So you want the outside. Please don't forget your infinities like I do. Okay. And to do a slightly harder example, let's say you have x plus 1 minus 3 is greater than 2, right? Same methodology, you isolate this piece, so you end up with x plus 1 is greater than 5, right? And again, we're looking at that radius, right? We want the solution of this to be bigger than 5, right? If we follow the same methodology as this, right, or even as this, you're looking at that external radii. So really you want negative x plus 1 is greater than 5, and positive, you can put the positive if you'd like, x plus 1 is greater than 5. And you work this out, you get negative x minus 1. You can also divide by negative and swap the sign, that's fine, I don't really care. Is greater than 5. Add 1 to both sides, negative x is greater than 6. X divided by negative 1, x is less than 6. Sorry, negative 6, my bad. On this side, you have x plus 1 is greater than 5, x is greater than 4, right? And graphically, you have negative 6 here, and you want less than, positive 4 here, and greater than. Okay? Okay. Now for grade scope purposes, I want you guys to do number 20 on, this is page 40, number 20, A, B, and C. I want you to do number 26, and I want you to do number 31, okay? And from here, I want it in graph notation, interval notation, and inequality notation. Okay. I want this on grade scope, due date, TBD.